All right, we're going to do the 130 sample final. So probably the easiest would be to make the table, but you could also make the Venn diagram, whichever you're more comfortable with. I'll do the table. The universe has 25, and this is all counts, that's why the ends. A complement, A complement, and then B and B complement. A has 13 in it. B complement has 9. And A intersect B has 20. A union B. That A union B, these three have 21, so that means if there's 25 total, that means 4 has to be there, because union is 3. So I was going to say there couldn't be 21 here if there's 13 here. So this is not 2, but this is 5, and so taking 5 from 13, we get 8 in the intersection. And if that's 13 and 25, 12 has to go there. 9 from 25 is 16. That means 8 has to also go there. So 8 and 4 is 12, 13, 25, 16, 9. Okay, the first one, A, the count of A intersect B complement. That's the one box, 5. A union B, the probability. The count is 21, so the 21 out of 25 is the probability. And the probability of B given A. So you can do it a couple ways. A is the denominator, which has 13, and those that are in B also are 8. You could do it that way. Or you could do the intersection. Probability of the intersection is 8 out of 25 divided by the probability of just A, which is 13 out of 25, and the 25s would cancel and give you 8/13. Are these independent? So since I found the probability of B given A, I will find the probability of B. And the probability of B is 16 out of 25. And it changed to 8 out of 13 if A has happened, and those are not equal fractions. So it's not equal to 8/13, so not independent. Again, I got to check the probability of A given a probability of B given A with the probability of B. They got to be the same first letter. All right. Number 2. How many ways are there to select the membership of a club with 32 members? So the club has 32 members, and how many are there to select from a president, vice president, secretary, and treasurer? That's 4 different distinct positions, so that's going to be arranging them. So I'm going to have to do permutations from 32 permutations on president, vice president, secretary, treasurer, 4 spots. So I'm going to do 32P4, which by formula is just going to be 32 times 31 times 30 times 29 times 28 factorial over 28 factorial. 32 minus 4, 28 factorial, which is just those numbers, which is 32 times 31 times 30 times 29, 86340. 86340. 3040. Number 3. Suppose a new drug causes some humans to have extraordinarily high IQ. Wouldn't that be great? And that 15% of the population takes the drugs. Of those that take the drug, only 7% actually get a high IQ, while 1% of the rest of the population also experiences high IQ. What is the probability that the person took the drug given they don't have a high IQ? So 15% take the drug, which means 85% don't take the drug, and then high IQ, high IQ, not high IQ. Why do I keep wanting to do not high IQ? There we go. H there, not an N. Okay. Alright, and those that take the drug, only 7% experience high IQ. 0.07, which means 0.93 don't have a high IQ. And let's see. Of those that take 7 actually experience a high IQ, while 1% of the rest of the population also have high IQ, so that's 0.01, 0.99. So we want to know what's the probability that a person took the drug given they don't have a high IQ. So this one does not have a high IQ, and this one does not have a high IQ. So those are the ones that don't have high IQ. So that's going to be 0.15 times 0.93 plus 0.85 times 0.99, and of those two, which one took the drug, which is the top one, 0.15 times 0.93. So that will work out to be 0.15 times 0.93, that's the numerator, divided by parenthesis 0.15 times 0.93 plus 0.85 times 0.99. And I get an answer 0.142. And that's the probability that they took the drug, that's this branch, out of all the branches where they don't have high IQ. Okay.